Hello my dear students. So I am going to continue with the lesson. So in this lesson we have been discussing many different properties of matter. So in the previous chapter also I discussed what density is. And you are familiar with pure substances and non-pure substances. And you all know pure substances have definite values for certain physical properties. So using that, for example, now we discuss density of water. Density of pure water is 1 gram per centimeter cube. So if we see that the water sample has a density of 1 gram per centimeter cube, we can say it is pure water. So similar to that, there are many other physical properties, and I told you all I will be discussing some more such physical properties. So the next property is melting point. Now you all are familiar with this concept, melting. What is melting? You take ice cubes from the freezer, from the refrigerator, from the freezer, you take the ice cubes out. If you put them into a cup and if you leave it aside for some time, you can see that the ice melts and becomes water. So when a solid becomes a liquid, we call it melting. Same way you have seen when we burn a candle, light a candle. The candle wax, the solid wax, melts to give liquid wax. So like that you have seen many examples where solids get converted to liquids. That is melting. And this particular melting process takes place at a particular temperature. And that is what we call as melting point. So if we look at what melting point, there is a fixed temperature at which a solid turns into a liquid. You have to remember that, students. There is a fixed temperature. That's very important. When the solid is becoming a liquid, the temperature doesn't change. Now, if you take a small amount of ice, you leave it outside, then you will see the temperature of ice will change. But when it is turning into a liquid, the temperature does not change. At a fixed temperature, all the ice will be converted to water. And that particular fixed temperature is what we call as melting point. This temperature is known as its melting point. Pure substances have a fixed melting point. So, for example, if we take ice. Now, you take a small container and into that, if you take a few ice cubes, and these ice cubes, ice will melt to form water. And that will happen at a fixed temperature. And then we will say that is the melting point of ice. Is that clear, students? So here we will say melting point of ice. Point of ice. And usually, students, at the normal pressure, the standard pressure, the melting point of ice is 0 degrees Celsius. So melting point of ice is going to be 0 degrees Celsius. So until all this ice is converted to water, the temperature will remain the same. Once everything becomes water, then you can see the temperature of water rising. That is where we discuss melting point. So since ice is made up of pure water, melting point of ice is a fixed value, 0 degrees Celsius. And that is what we are going to understand in this activity. So if we go back to the activity here, activity, find out whether the melting point of pure substances has a constant value. So I told you, there it is given to you, pure substances have a fixed melting point. So when we say fixed melting point, water is a pure substance, so it should have a fixed melting point. That is what we will observe now. So activity, find out whether the melting point of pure substances has a constant value. Constant value, fixed value, it's the same thing. For that, we need these materials. First, we have a boiling tube. This is a boiling tube. Then we need a beaker. Then we need water. We need a thermometer. Then we need a stirrer to mix the solution. Then we need a stand. We need a stand to fix the boiling point so that we can heat it easily. And then we need Bunsen burner. Now you need a boiling tube, a beaker, water, then there is thermometer, there needs to be stirrer, stand and Bunsen burner. Now we are going to check whether melting point of pure substances has a constant value. So as the pure substance, we are going to take ice. So we need that as well. Ice cubes. Ice cubes, or you can say ice chips. Ice chips would be more better because they are smaller. Then you can insert the thermometer easily into that, and that is going to be our pure substance. So then what do? We take ice chips into a boiling tube. Then we take a beaker. Into that we pour some water and we set the beaker so that Bunsen burner heat will be provided to the beaker. At the same time, we fix the boiling tube using the stand within the beaker. So initially heat will be provided to the beaker containing water. The water will become hot and thereafter the heat will be transferred to the boiling tube. And we will have to connect the thermometer into the boiling tube that should be placed within ice. The tip of the thermometer has to be inside ice. So when we provide heat, while providing heat, we will be using the stirrer to mix water so that the temperature will be distributed evenly. So you will get a proper thermometer reading. Is that clear, students? So while providing heat, you need to observe the thermometer reading. I am sure you all know when you provide heat, obviously the temperature has to increase. There should be a change. So you will be expecting an increase in the thermometer reading. We will have to observe and see how it changes. So at the same time, you can also see the ice chips melting and forming water. So that is what we need to observe. That is the basic idea of the activity. I will go to the next slide and discuss the method again with you all, and thereafter we will do the activity. Method. So like I told you all, students, here you can see this is the stand. Now you have the stand here. This is a tripod. That is also needed. Normally when we do an activity, although we don't give everything in materials, there are some materials that we always use from the lab. So we need to have the tripod, then we will be having the Bunsen burner here. The stand is there, you can see it has been clamped. So here we have the boiling tube with ice chips. And inside the ice chips, you have the thermometer. You can see that here, I told you all this part, the bulb of the thermometer has to be inside ice. It has to be completely covered with ice so that you get the correct reading. Then here you can see we have the stirrer. So with the stirrer, you can mix this water. What will happen? Now Bunsen burner is burning. The heat will be given to the beaker. Then from the beaker, heat will be supplied to water. The water inside the beaker will become hot. We will be stirring the water so that the heat is distributed evenly. And then due to that heat, the boiling tube will become warm. So when that becomes hot, the ice will get heat. So then you will see what happens to ice. You can observe the thermometer reading as well. So that is the way we prepare the setup to do this activity. This is what we do. Fill about 1/4 of a boiling tube with ice chips. Quarter of the boiling tube with ice chips here. Arrange the apparatus as shown in the figure. So like this we have to arrange the apparatus. Heat till the ice melts. So when you start providing heat, you have to wait until all the ice melts. Stir the water well using a stirrer. So you know why we need to stir the water, so that heat is supplied, or we can say distributed evenly. Tabulate temperature against time. So there is a table given in your textbook. You have to fill up that table. That is temperature against time. In the first column, you need to have the time. Initially, when you start the activity, what is the temperature? And with time, usually we will be taking the reading every 15 seconds. So tabulate against time. Every 15 seconds. So it depends, students. You can even tabulate the reading every 10 seconds if you want. 15 seconds. So if the time limit is smaller, you will be taking more readings, but it will be more accurate. So 10 seconds or 15 second intervals is more than enough. This is what we need to do. So while you observe the ice chips melting, you have to note down the thermometer reading. You have to tabulate it against time. Is that clear to you all? So I am sure, students, you all can understand this activity clearly. So now we'll go to the lab and do the activity now. Okay, students. So now by doing this activity, we will try to understand that the temperature at which a solid melts into a liquid, that is the solid of a pure substance melts into a liquid, is a constant value. And we call that value as the melting point. So to do this activity, I have the Bunsen burner here. Then you can see the tripod with the wire mesh is set up here. And also I have connected a boiling tube to the stand, and also the thermometer is connected. Here I have the stopwatch so that you can measure the temperature change with time. So I have already prepared the table also. This is to observe the melting point. So we have time in seconds and temperature we will be measuring in degrees Celsius. Initially, if you look at the temperature, the thermometer reading, you will see it will be the room temperature. So normally the room temperature here, it's about 21 degrees Celsius. So then I have this beaker containing water. So inside the water, I have a stirrer as well. If we mix the water well, then the heat will be distributed evenly. You will get a proper temperature reading. Then I have ice here. So what I will do is, I will put the ice, transfer the ice into this boiling tube. I will transfer some ice chips into the boiling tube. You have to look at the thermometer reading. We will have to fill about 1/4 of the boiling tube with ice. I think I have taken enough ice. Now if you look at the thermometer reading, students, you can see the temperature is dropping. So it will decrease to the temperature of ice. You all can look at the thermometer reading. It's decreasing. So initially the temperature we will take it as time 0 and we will take the temperature. I'll wait till the temperature decreases and comes to a fixed value. Now students, you all can see the temperature has decreased to 0 degrees Celsius. At this point, I will have the beaker with water. So, initial temperature, if you see, we will take it as 0 degrees Celsius. So, then I will have to provide heat. At the same time, I will be starting the stopwatch. Now you all can see students, the temperature has gone down further. It has come to -1 degree Celsius. So we will take that as the initial temperature. Then I will provide heat. As you know students, ice will be below 0. It can even go up to -5. You all know in cold countries the temperature really goes down. So ice can exist in very low temperatures as well. So here the temperature is -1. So now I will provide heat. I will provide heat at the same time. I will start the stopwatch. So we will look at the temperature every 5 seconds initially. After 5 seconds also you can see the temperature reading still -1. About 10 seconds. The same. 15 seconds also you can see the reading. Now it has become 0. So we will take 15 seconds as 0 degrees. After 30 seconds, 0 degrees Celsius. So even I'll wait for another 15 seconds, but if the temperature changes, we can see almost 45 seconds, till it is 0. So 45 seconds also, the temperature is 0. So we will wait till it goes to 1 minute. You can see little by little now I have to mix this also. Now the ice is melting after 1 minute. Still you can see the temperature as 0 degrees Celsius. But also you can observe the ice melting. So there's water and ice as well. So 1 minute 0 and 1:15 also. If you see, the temperature is still 0. So I'm still providing the heat. 1:31.5 minutes. Still you can see students, there is ice as well as water inside. So it has passed 1 minute and 45 seconds. Even at the end of 2 seconds, you all can see the temperature is still 0 degrees Celsius. There is ice and water. So this is 2 minutes also. I will make it as 0 degrees Celsius. We will have to wait until all the ice melts to water. Now you can see students, after 2.5 minutes, the temperature became 1 degree Celsius. So now if we wait till the end of 3 minutes, almost closer to 3 minutes. Now you can see it has become water. The temperature, it's about 3 degrees Celsius. So 3 minutes students, you can see 3 degrees Celsius. So we will see. Now we will just wait till 3.5. You can see the temperature rising. It's about 4 degrees Celsius. So we will take the reading till about 4 minutes. Now it is 5 degrees Celsius. So that is at the end of 4 minutes, it's 5 degrees Celsius. So from these observations, students, you all can see here, initially the temperature was minus 1 degree Celsius. That was the temperature of ice. Then we saw when we started providing heat, the temperature increased to 0 degrees Celsius. That is after 15 seconds. And thereafter, from 15 seconds to 2 seconds, the temperature remained at 0 degrees Celsius. And at that time, you all were able to observe that the ice melted to water. So that is the temperature at which the solid ice becomes liquid water. That is the melting point of ice. So you can understand, since ice is a pure substance and the melting point of ice remain constant at 0 degrees Celsius. So from that we can confirm that melting point is a constant value for all pure substances. Okay, students. So did you all get all the observations clearly? Can you all remember what happened? Yes. You saw the ice starting to melt, and with that you were able to see the thermometer reading clearly. And you can remember, I wrote down the thermometer readings with time. And I got the readings every 15 seconds. So initially, when we started, can you remember the temperature? It was minus 1 degree Celsius. So I'm going to write down the values here first. So initially time I read in seconds and temperature it was in degrees Celsius. So initial time, so time 0, the temperature reading was minus 1. Then after 15 seconds, the temperature reading was 0, then 30 seconds, it was 0, 45 seconds, it was 0, then 1 minute, or we can say 60 seconds. In brackets I will say 1 minute. Again it was 0. Then after that 75 seconds, that is 1 minute and 15 seconds. That was also 0. Thereafter, you can remember, students, at the end of 2 minutes, that is 120 seconds, that is 2 minutes. Still the temperature reading was 0 seconds. After that, when we came to 150 seconds, that is 2 minutes and 30 seconds. What happened there? The temperature became 1 degree Celsius. Thereafter, when it came to 3 minutes, that is 180 seconds, here it is 3 minutes. Then the temperature became 3 degrees Celsius. The temperature became 3 degrees Celsius. And finally, when it was 210 seconds, that is 3 minutes and 30 seconds, the temperature reading was 4 degrees. After that also, I took a reading that was at the end of 4 minutes. The reading was 5 degrees Celsius. So you all were able to see all these temperature readings. What did we understand from that? Now you can see, starting from time 0 until 120 seconds, that is until the end of 2 minutes, what happened? The temperature did not change. During that time, what did you all observe? You saw the ice chips melting and forming water. And at the end of 2 minutes, you saw that all the ice chips was converted to water. Ice chips melted and there was only water. Thereafter, here when we continued, you were able to see it was only water, but the temperature reading started increasing. So can you all understand the concept now? Initially, it was ice minus 1 degree Celsius. Then the ice absorbed some heat. When we provided the heat, it came to 0 degrees Celsius. And thereafter, when the temperature remained at 0 degrees Celsius, all the ice melted and formed water, or the ice melted to form water. Until all the ice melted, there was no change in temperature. Only when everything completely melted, the temperature of water started rising again. So from that, we can conclude and say ice melts at 0 degrees Celsius. That is, melting point of ice is 0 degrees Celsius. Is that clear to you all? So that is what we need to write as conclusion. So here, we can say when ice melts to form water, the temperature remains a constant value. That is, ice melts at 0 degrees Celsius. Or we can say melting point of ice is 0 degrees Celsius, and it is a fixed value. So ice is a pure substance and ice has a fixed melting point. So if you know the melting point of a substance, by measuring the melting point, you can identify the pure substance. Is that clear to you all? So this is the other physical quantity. There are some more melting point. The temperature at which a solid melts and forms the liquid is known as the melting point. For pure substances, the melting point is a constant value. That is what you need to understand from here. So if we go back and quickly check, these are the readings that we got. We tabulated time and temperature. We measured the temperature against time and we have the table. And at that point, you were able to see, at this point, you were able to see ice melted and, or we can say ice melts. And within this time period, when the temperature remains at 0 degrees Celsius, the ice melts. That is what you saw. So from that, we were able to come to this conclusion. When ice melts to form water, the temperature remains a constant value. That is, ice melts at 0 degrees Celsius. Or you can say melting point of ice is 0 degrees Celsius. I am sure students, you all can understand this concept clearly. So with that, I will move on to the next slide. When heat is supplied, matter turns from the solid state to liquid state without changing its temperature. The specific temperature at which this change in state occurs is called the melting point. So you have to remember this very well. The specific temperature at which this change in state occurs is called the melting point. So inside the beaker, you have ice that completely melts to form water, and that happens at a fixed temperature, and that is known as melting point. So as an example, if we take melting point of ice, you have a beaker here Then you have the same beaker there. Here it will be, here you take a piece of ice. Melting point 0 degrees Celsius. Constant value for pure substances. So here we have ice, here we have water. Can you all understand this? So we have ice that melts and forms water. Until that happens, the temperature remains constant, that is 0 degrees Celsius, and that value is known as melting point. And this is at standard pressure. So here you can see, in the above experiment, the temperature remained at 0 degrees Celsius until all ice turned into liquid water. So, the melting point of pure water at normal atmospheric pressure. The normal atmospheric pressure is 0 degrees Celsius. Is that clear to you all? So, when we say normal atmospheric pressure, that is the melting point. Melting point 0 degrees Celsius, constant for pure substances at, we can say, normal atmospheric pressure. So that is how we define melting point. And by using the melting point, we can identify pure substances. You have to understand that. So to get a little bit more understanding, I will move on to the next slide. Here you can see melting points at standard atmospheric pressure of some pure substances are given. So we use the term normal atmospheric pressure, we use the term standard atmospheric pressure. Standard atmospheric pressure is the pressure at which we compare the melting point of substance. So here you can see substance is given in the first column, melting point is given in degrees Celsius. First one is ice. So 0 degrees Celsius. What I said as standard atmospheric pressure and what is given as normal atmospheric pressure is the same value. So in that, the melting point of ice is 0 degrees Celsius. We always say the solid first because solid is the one that is going to melt. So if water is going to freeze, it will become ice. That also happens at the same temperature. There we say freezing point. So when we say melting point, you have to remember, students, it is the solid that is going to become the liquid. So you always have to say melting point of ice. You don't say, if you say melting point of water, that is wrong. That is incorrect. So you have to say melting point of ice because ice is the solid form, water is the liquid form. Solid turns into liquid at the melting point under standard atmospheric pressure. So melting point of ice is 0 degrees Celsius. Then sulfur. Sulfur you all can remember an element, a yellow color shiny solid substance. Sulfur. Now sulfur has a melting point of 132 degrees Celsius. Then lead. Lead is a metal you all can remember. Lead has a melting point of 317 degrees Celsius. Then aluminium. Aluminium 660 degrees Celsius. That is also a metal. Then copper 1083 degrees Celsius, a very high value. Now you can see 0 degrees Celsius, 132, 317, 660, 1083. Then iron. Iron again you all know is a metal, 1539. So can you see the melting points are very, very high. Now, out of all these, I said everything is solid. Now, do we get ice normally at normal temperature? At room temperature, we don't have ice. Only when we keep the water inside the freezer, you get ice. When you take it out, keep it outside in the room temperature, it becomes water. Now, think about the melting point. 0 degrees Celsius. That is a very low value. Normally, our room temperature is about 30 to 35 degrees Celsius. So, the melting point of ice is less than the room temperature. That is why normally we have water. Ice can be obtained by placing water in the freezer. But all these, look at all the rest of the substances. Sulfur, lead, aluminium, copper, iron, all these are present as solids in nature. So that is because all of them have very high melting point. Can you all understand that? You have to remember this as well. All of these have very high melting point. Out of those, if you take these, I told you all they are metals. Metals have comparatively high melting point. So we will be classifying these substances as metals and non-metals based on these physical properties. So then also I will remind this to you all. You have to remember. Usually metals have high melting point. That is why normally metals are solid. Normally, usually most of the metals are solid. You have to remember that, students. So the melting point of pure substances is a constant. Again, important. Melting point of pure substances. So these are all pure substances. Ice is pure ice. Pure water becomes pure ice. Then sulfur, element, lead, aluminium, copper, iron. These are all pure substances. Why? They are all elements. So melting point of pure substances is a constant. Those are the values. Therefore, the purity of a substance can be determined by measuring its melting point. So when you measure the melting point of a substance, you can determine whether it is a pure substance or a non-pure substance. If you think there is a metal, lead. If you determine the melting point doing an activity like similar to what we did before, if it is 317 degrees Celsius, you can confirm and say that it is lead metal. But let's say if it becomes 320 degrees Celsius, then it is not the pure lead metal. There can be an impurity. Some other substance is mixed with lead. Sometimes it can be less than 317. It can be 300 degrees Celsius. Then also it means it is not pure lead. There is something mixed with lead. So pure substances will have a fixed melting point. But if it is not pure, the melting point can increase or decrease depending on what is mixed with the pure substance. Can you all understand that? So all these substances in their pure form will have a constant melting point. You have to understand that. With that, students, I am going to move on to the next slide. So then we have another physical property, boiling point. Now you all know what boiling point is, no? Every day you all drink something hot, either tea, coffee, milk. So you all would have seen someone, an adult at your household, boiling water, boiling milk. So there what happens? You have the liquid water. When it boils, now let's say by mistake, now your mother or someone at home, they keep a container of water, a pan of water to boil, a kettle of water to boil, and if they forget to turn off the cooker, what will happen? The water will continuously boil, it will become steam, and until all the water become steam, it will keep on boiling. And thereafter the vessel will start burning. Then only they might realize that they haven't turned off the cooker. So at that point, when all the water is being converted to steam, that is water vapor, we call that as boiling. And that also takes place at a constant temperature. So that temperature is known as boiling point. So again, pure substances have fixed or constant boiling points. So boiling point. There is a definite temperature, very important. There is a definite temperature at which a liquid turns into a gaseous state. That temperature is known as its boiling point. And you can see pure substances have a constant boiling point. Very important. Pure substances have a constant boiling point. Then we have the activity. So, like we did before, we are going to find out whether there is a constant value for the boiling point of pure substances. So, if you take water, now let's say you take a beaker of water, like I explained before. You take a beaker containing water, you provide heat. So what will happen? From this, steam will be released when it starts boiling. When it starts to boil, there will be steam released. So until all the water is converted to steam, that is water vapor. Vapor, that is the gaseous state. This is the liquid state. So this particular temperature is what we call as boiling point. So until all the water is converted to steam, the temperature will remain a constant. And for water, the boiling point is 100 degrees Celsius. And that also at standard pressure. So the boiling point of water is equal to 100 degrees Celsius. Now you can imagine what we are going to do. What do we need to do during the activity? We need to find out whether there is a constant value for the boiling point of pure substances. So now that you know the boiling point of water is 100 degrees Celsius. Like we did before, we have to tabulate the temperature against time. So while doing that, you have to observe whether the temperature remains a constant. So to do that, again we need a boiling tube. Here we need water. We are going to observe the boiling point of water. Then we need a thermometer. Like before, we need a stand and we need a Bunsen burner. So what do we do now? You have the Bunsen burner. Above that, you have to set this boiling point. Into that, you take water and you place the thermometer inside that. And while providing heat, you observe the thermometer reading and also you have to time it. Initially, you have to take the thermometer reading. It will be usually the room temperature. Then when you provide heat, you can see the thermometer reading increasing. It will reach the constant value. It will reach at a certain temperature and will remain constant. If it remains constant, we can say it is pure water. And we can measure the boiling point of water. Is that clear to you all? So that is the concept of the activity. I will move on to the next slide, where I will discuss the method again and then we will do the activity. So the method. Now this is what we are going to do. You have the stand here. The stand is marked there. You can see the boiling tube is clamped to the stand. This is the boiling tube. Boiling tube. So in that we take water and the thermometer is fixed there. And you have to observe the thermometer reading. You have to tabulate it with time. And we provide heat using the Bunsen burner there. Now this is the method. Add water to a boiling tube and fix a thermometer as shown in the figure above. Like this, the thermometer is slightly above. You don't really put it into water, slightly above but very much closer to the surface of water. So there we fix the thermometer. Heat the water with the burner. So using the Bunsen burner, we heat the water. Tabulate the change in temperature with time. So here also, according to the time, we have to tabulate the temperature. Is that clear, student? So it's a simple activity. Only thing we have to make this apparatus, we have to set it up like this and then we need to provide heat and with time, we need to tabulate the temperature. At the same time, you have to observe what happens to water. You will be able to see water boiling. At that time, you have to note the temperature reading. Is that clear to you all? So then, we'll go to the lab and do the activity now. Okay, students. So now we are going to do this activity in order to understand that the boiling point of a pure liquid is a constant value at a given temperature. So if you look at what boiling point is, what is boiling point? The constant temperature at which a liquid turns into its gaseous state. That will be the boiling point at that given pressure. So now if we take the room pressure, that's a constant value. And if you look at the pure liquid that we are going to use, that is going to be water. So I have taken water into a boiling tube. You all know we have to use a boiling tube when we need to heat something. So here I have the Bunsen burner ready to use and the boiling tube has been clamped and also you can see the thermometer clamped inside that. But here if you notice carefully, students, the thermometer is not in contact with the water. The reason is here when water boils, water is the pure liquid and the gaseous state is going to be the steam. The water and the steam will have the same temperature. So we are going to get the temperature of steam with time. Initially, if you look at the thermometer, now this is at room temperature. Can you all see the temperature reading? It's 27 degrees Celsius. So here I will just note it as room temperature RT 27 degrees Celsius. Initially when we supply heat, you all know what should happen. The temperature of water will increase. Thereafter, you will see that the temperature has to remain at a constant value when there is boiling and until all the water turns into vapor or steam, the temperature has to maintain at the same value. Thereafter again, it will start increasing but there will be no water left there. So until all the water becomes steam, the temperature has to remain constant. And you all know the boiling point of water is 100 degrees Celsius. So now I am going to supply heat and when I supply heat, I will start the stopwatch. So with time, we will get the thermometer reading. So now as I place the burner under the boiling tube, I will start the stopwatch. So here we will see the change in temperature. So you can see the time is coming almost to 15 seconds. The temperature is still around, it's about still 28 degrees. So we'll take the reading after 30 seconds. It's 28. So I'll wait till it comes to 1 minute and I will record the temperature. After 1 minute, it is 34 degrees Celsius. So, that I will take as the first reading, 34 degrees Celsius. So, we'll wait until the temperature increases. So, there you can see the gas bubble starting to come out as the temperature increases. You can see it's almost 39 degrees Celsius after 1.5 minutes. It has become 40. So, if we take the temperature 2 minutes, you can see the temperature has gone up to, now you can see the temperature is at 100 degree, almost closer to 100 degrees Celsius. The time is 2 minutes and 30 seconds. So, the temperature is nearing 98. So, now you can see the boiling process. So, if we take the temperature as 3 minutes, now you all can see students, 3 minutes, it's 100 degrees Celsius. So, we will wait and see. Now you all can see students, the water is boiling and the temperature is at 100 degrees Celsius. So, we can say even at 4 minutes, it is at 100 degrees Celsius. So, you all can also see that the volume of water that was inside, it is decreasing. So, now even after 5 minutes and also almost closer to 6 minutes students, now you can see almost all the water has evaporated and still the reading is 100 degrees Celsius. So, from that we can now almost the water has evaporated. Now, I'll remove the burner. So, you all can understand students, when the water was boiling and the liquid water was being converted to the gaseous state, that is the steam, the temperature remained at 100 degrees Celsius. So, again I haven't recorded the temperature with equal time intervals because it was changing. So, initially you can remember students, the temperature was 27 degrees Celsius, that was the room temperature. Once we started supplying heat, then of course you were able to see that the temperature increased to 34 degrees, that is after 1 minute, and by the end of 2.5 minutes it was about 98 degrees Celsius, and from 3 minutes onwards until the end of 6 minutes the temperature remained at 100 degrees Celsius and almost all the water evaporated off. So, you can see there's only a very tiny amount of water left. If we further continued providing heat, that also would have got converted to steam, that is the gaseous state. So, from these observations students, you all can understand that when there is boiling, the liquid turns into its gaseous state at the boiling point, and the boiling point has a constant value for the given pressure. Okay students, so did you all observe the temperature readings clearly? So, with time, I noted down the temperature, you can remember. So, initially, when I measured the temperature of water, it was 27 degrees Celsius. Then you were able to see gradually the temperature increased and it came to 100 degrees Celsius, and thereafter it remained at 100 degrees Celsius while water boiled. And you were able to see the steam coming up. So, the boiling point of water is 100 degrees Celsius. That did not change. So, first I will write down the observations, time and temperature. What I noted down during the activity. So, initially we measured the temperature. What was the temperature? It was the room temperature. That was time initially 0. We had the room temperature temperature, and temperature we measured in degrees Celsius, and it was 27 degrees Celsius. You can remember that. That was the normal temperature. Then after that, I took the temperature reading after starting to give heat after 1 minute. So 1 minute, what was the temperature? It became 34 degrees Celsius. Then thereafter, I measured the temperature when the time was 2 minutes and 30 seconds. So at that time, what was the temperature? It came to 98 degrees Celsius. After that, 3 minutes. Temperature was 100 degrees Celsius. Thereafter, I continued observing the temperature until 6 minutes. So 4 minutes, 100 degrees Celsius. 5 minutes, 100 degrees Celsius. Then 6 minutes, it was 100 degrees Celsius. This is what you all observe. So these were the readings that we got, students. You can remember initially it was the room temperature 27 degrees Celsius. After providing heat, after 1 minute, it was 34 degrees Celsius. 2 minutes and 30 seconds, it was 98 degrees Celsius. Quickly the temperature rised. Why? It took only a small amount of water. And thereafter, from 3 minutes onwards, you were able to see that the temperature reading was 100 degrees Celsius. So even if we continue for some more time, you will see that the temperature will remain at 100 degrees Celsius until when? Until all the water becomes steam. So thereafter, if you measure the steam, it's difficult to measure. Why? Steam just spreads out. So there, all the water will become steam at 100 degrees Celsius. So that is the boiling point of water. So from this, what can we conclude? We can say water boils at a constant temperature of 100 degrees Celsius. Water boils at a constant temperature of 100 degrees Celsius. Or in other words, we can say boiling point of pure water is 100 degrees Celsius under standard pressure. So here also it's very important. Now you might be wondering, why even with melting point we said standard pressure, now also we are saying standard pressure? Because the melting point and boiling point, they depend on pressure. When the pressure is standard pressure, then pure water boils at 100 degrees Celsius. But if the pressure decreases, then of course water will boil at a temperature less than 100 degrees Celsius. So when pressure changes, the boiling point also changes. That is why when you state the boiling point, you have to say at standard pressure or under standard pressure. That is very important. Can you all understand that, students? I'm sure you all can. So with that, we'll move on to the next slide. When water is heated, temperature rises gradually. So gradually, little by little, temperature rises. At a certain moment, the rise in temperature stops and water turns into vapor state from the liquid state. So at a certain moment, the water gets converted to vapor. That is, from liquid state, it goes into the gaseous state. That temperature remains unchanged till all the water is vaporized. Until all the water is vaporized, the temperature does not change. That temperature is called the boiling point of water. And that temperature is called the boiling point of water. The boiling point of pure water at standard atmospheric pressure is 100 degrees Celsius. That is very important. This part is very important. The standard atmospheric pressure, the boiling point of pure water is 100 degrees Celsius. The boiling point of a liquid depends on the surrounding pressure. What I told you. The boiling point of a liquid depends on the surrounding pressure. If the surrounding pressure falls, the boiling point falls. The boiling point of water on a high mountain is lower than 100 degrees Celsius. Why a high mountain? You all know, students, when the altitude increases, the height increases, the pressure, atmospheric pressure, decreases slightly. So at a high mountain, the atmospheric pressure will be less than the normal or standard atmospheric pressure. So then water will boil at a lower temperature. Boiling point of water will be less at the top of a high mountain. You have to remember that as well. So you have to remember all these points. When a pure substance, that is a pure liquid, is converted to its vapor, the temperature remains a constant at standard pressure, standard atmospheric pressure. And that temperature is what we call as boiling point. So pure substances has a fixed boiling point. But this boiling point will change when the atmospheric pressure changes. At higher altitudes, the atmospheric pressure is less. Because of that, the boiling point will be less. Is that clear to you all? So then, if water is not pure, due to the dissolving of foreign substances. So when foreign substances dissolving of foreign substances, the boiling point, that is 100 degrees Celsius, may be elevated or lowered. That is something you have to remember. It can be elevated or lowered. I told you all this when I explained melting point also. So here in water, if some substances dissolve, then water might boil at 105 degrees, which is more than 100, or it can boil at a temperature lower than 100. So the boiling point can be elevated, that means increased, or lower, can be decreased if it is not pure, if there are other substances dissolved in it. Is that clear to you all? From this, it is clear that the boiling point is also a physical characteristic that can be used to probe the purity of a compound. So, boiling point can be used to probe the purity of a compound. You have to remember that. So, to identify whether water is pure or not, you can use its boiling point. If it is 100 degrees Celsius at standard pressure, then it is pure water. If the boiling point is not 100 degrees Celsius at standard atmospheric pressure, that means there are foreign substances dissolved in water. This is something you all have to remember, students. Is that clear to you all? So then we will move on to the next slide. Boiling points of some substances under normal atmospheric pressure are given to you in this table. So the first column gives you the substance and the second column boiling point, that is given in degrees Celsius. You have to remember this is at normal atmospheric pressure or standard atmospheric pressure. Very important. Normal atmospheric pressure. Here you can see all the substances are given to you. They have to be in their liquid state. So here the liquid will be converted to the gaseous state. So then we call it boiling point at standard atmospheric pressure. So ethyl alcohol, ethanol, same thing. Ethyl alcohol is also called as ethanol. That is a liquid. And the boiling point of ethanol or ethyl alcohol is 77 degrees Celsius. You can see that is less than water. So ethyl alcohol will boil faster than water. If you have equal volumes of ethyl alcohol and water and under the same pressure, if you provide the same amount of heat, ethyl alcohol will start boiling at 77 degrees Celsius, whereas water will boil at 100 degrees Celsius. So you can compare. Boiling point of ethyl alcohol is less compared to boiling point of water. Then we have sulfur. Now earlier I told you all sulfur is a solid. Same goes for lead. Lead is a metal, it's a solid. Iron is a metal, that is also a solid. But when we discuss boiling points, we consider these also liquids. Liquid state, not the solid. So first we saw the melting point. The solid will become liquid once it becomes liquid. So liquid sulfur, liquid lead, liquid iron. They will become vapor. So that is their boiling point. Now look at the values there. For sulfur, 444 degrees Celsius. Very high boiling point. Lead, 1744 degrees Celsius. Very, very high compared to water and ethyl alcohol. Iron, liquid iron will boil at 2900 degrees Celsius. That is also a very, very high temperature. So if you look at all these values, 77 degrees Celsius, 100 degrees Celsius, ethyl alcohol and water. The others, which are normally solids at room temperature, have very high boiling points. Is that clear to you? So you can relate their melting point and boiling point to how they exist in nature as well. Solids have to melt first, they have to become liquid, then only they have to boil. So that is why their boiling points are very high. Here, so since we say boiling point, we consider the liquid state. Consider liquid state. Although normally they are solid states, you consider the liquid state. Is that clear, students? So you have to know what boiling point is, and at the boiling point, a liquid is converted to its gaseous state or vapor. And if it is a pure substance, the boiling point is a constant value under standard atmospheric pressure. And if the pressure decreases, boiling point will decrease. Or else if it is not a pure liquid, if something is foreign substance is dissolved in it, then also the boiling point will change. You have to remember that. So if it is a solid substance, normally if it is a solid substance, if you are considering the boiling point, you have to consider that they have been melted and you get the liquid and the liquid has to boil. That is how we get the boiling point for these substances. Is that clear to you? Again, I told you all students, we will be considering this to classify substances as metals and non-metals. Here also you can see lead and iron, they are metals. Look at their boiling points. Very, very high compared to the other values. So normally or usually metals have very high boiling point. We saw that they have very high melting point. Similarly, they have very high boiling point. So those are the information you can get from this slide. I'm sure you all can understand all those, students. So with that, I'm going to end this chapter. So in this chapter, we discussed two physical properties, the melting point and boiling point. And you all know melting and boiling point of pure substances is a constant value under standard atmospheric pressure. In addition to that, there are some more physical properties. So in the next chapter also, I will discuss some more physical properties with you.